My phone begs for charge every night. The water timer on my garden tap runs on a set of AA batteries. Outdoors, rained on from spring until autumn. Same batteries, all season, holding back mains pressure the whole time. Here's the question, how? Inside that plastic box are two of the cleverest tricks in the whole garden. A valve with a memory and a gate the water opens itself. Today the lid comes off. Take the lid off a battery water timer, and there is less in there than you might think. A small circuit board with a clock on it, a battery holder, and one component that actually matters, a solenoid valve, sitting in the water path like a gate across a road. That gate has two jobs. Job 1, move. When the clock says 6 in the morning, something physical has to shift, and shift back again when the watering is done. Job 2, hold. Mains water in Britain commonly arrives at anywhere from 1 to 6 bar. That is a serious shove, and it presses on that little gate every minute of every day, wanting through, and the whole operation has to run on the pocket money of a few AA cells. There is no mains electricity out at the tap. There is no motor slowly winding a spindle open either, because motors are greedy and slow. Just a coil of wire, a sliver of metal, and some genuinely tidy thinking. So that is the puzzle of the episode. 2 jobs, 2 tricks. The first trick is how the gate moves without draining the batteries. The second is how it holds back 6 bar with no muscle of its own. Start with the moving. First, what a solenoid actually is, because the word sounds grander than the thing. Wrap a length of wire into a coil and pass a current through it, and the coil becomes a magnet. Sit a small metal plunger inside that coil, and when the coil wakes up, the plunger gets pulled. That is a solenoid. An electric finger. Current on, the finger pulls, current off, a spring shoves the plunger straight back. No gears, no motor, one moving part. Your washing machine lets water in with one. Your dishwasher does the same. But notice the catch. An ordinary solenoid valve only stays open while the current keeps flowing. The spring never stops pushing, so the coil has to keep fighting it for as long as the water runs. It is like holding a door open with your arm out straight, easy for 1 second, exhausting for an hour. Plugged into the wall, nobody cares. The washing machine can afford the habit. But your garden timer lives off AA batteries, and a watering window is long, 20 minutes here, half an hour there, morning after morning. If the coil had to stay powered through all of it, those batteries would be flat long before the tomatoes ripened. So the ordinary solenoid is a dead end. The timer needs the pull without the holding. Here is trick 1. The latching solenoid. Engineers say B-steeble, which is a fancy way of saying it has 2 resting places. Throw away the spring that fights you and fit a small permanent magnet instead. Push the plunger to the open end and the magnet grips it there. No current, no effort, it simply stays. Send one short pulse through the coil and the plunger flips across to the other end and the magnet grips it there instead. Shut. Reverse the pulse and it flips back. Electricity is only spent at the moment of change. In between, whether the valve rests open or rests shut, the current is 0 and the magnet does the remembering. On my bus, a passenger presses the bell once and the sign stays lit until I open the doors. Nobody stands there holding the button all the way down the Falls Road. One press, remember. Same idea, cast in brass and copper. So a battery timer on a once-a-day schedule spends electricity twice. 1 pulse to open the valve at dawn, 1 pulse to close it 20 minutes later. Each pulse lasts a fraction of a second. Everything in between, the timer is doing nothing but counting, and counting is nearly free. That is the engineering joke at the heart of it. The valve does not sip power slowly, it spends nothing, then a blink, then nothing again. And that little joke buys you the whole summer. The spec sheet on my own timer says a set of AA alkaline cells is good for 6 to 8 months of typical daily use. 6 to 8 months. That is an entire British watering season, first sowings to the last tomatoes, on the same batteries you would feed a television remote. The app flags them below 20% too, so the box even tells you when it is getting peckish. This is why the humble hose timer quietly wins every holiday. While someone is begging a cousin to come round with a watering can, a latching valve just keeps flipping, morning after morning, whether you are home or on a beach. One gardener on Reddit put it the way most of us feel it. They had rigged a drip line onto a cheap hose timer before going away, and came home to a garden that had simply carried on without them. Nothing beats it, they said. 3,000 people agreed. But hold on, because something should be bothering you by now. Each pulse lasts a fraction of a second, off a few small batteries, a polite little blink of current. Meanwhile, the mains is leaning on that valve with up to 6 bar, every minute of every day. A blink cannot arm wrestle 6 bar. So why does the water do as it is told? That is trick 2, and it is the better of the pair. Trick 2. The valve never fights the water, it recruits it. Inside the valve body sits a disc of rubber called a diaphragm, resting over the outlet like a lid on a drain. Above the disc is a small sealed chamber, and a tiny bleed hole lets mains water seep up into it. So the same pressure that wants to barge through the valve is also sitting on top of the lid, pressing it shut. And the top face of the disc is larger than the bit exposed below, so the push from above wins. Think about that for a second, because it is lovely. The water holds itself back. 6 bar trying to break in becomes 6 bar holding the door closed, which means the solenoid is left with one tiny job. At the top of that chamber is a second little opening, the pilot, and the plunger we met earlier is simply a plug for it. When the pulse flips the plunger, the pilot opens, and the trapped water above the diaphragm escapes downstream. The pressure up top collapses. The mains below shoves the disc up out of the way, and the valve is wide open, moved entirely by the water's own strength. Close the pilot, the chamber quietly refills through the bleed hole, and the disc settles back down shut. When I brake the bus, my right foot does not stop a busload of people by muscle. Compressed air does the stopping. The pedal only asks. This valve is the same. The batteries ask, the water does the work. Now the small print, because a trick this clever has a blind spot. A valve that borrows the water's pressure needs some pressure to borrow. On the mains, no bother, but plenty of you are eyeing up a water butt on a stand, planning to run a timer straight off it. Here is the physics. 10 meters of water column gives you about 1 bar. So a butt raised 1 meter above the tap offers roughly 1/10 of 1 bar. That is not a shove. That is a polite lean. Fire the timer and you will hear the solenoid click. The pilot duly opens, and then nothing happens because there is nowhere near enough pressure to lift the diaphragm or to snap it shut again afterwards. The click without the water. You see that exact confused post on the gardening forums every spring, and it is nobody's wiring at fault. It is the right timer on the wrong water source. There are honest ways round it, low pressure kits and small pumps, and gravity systems get a full episode of their own later this series. For now, hold on to the rule. A pilot valve runs on borrowed pressure, and a water butt has barely any to lend. Which brings me to the kit on my own tap, because you have now met everything inside it. It is the Johgee 4-zone timer. 4 outlets off 1 tap, each zone on its own schedule. So the greenhouse drip and the lawn sprinkler stop arguing. It runs on the same AA alkaline cells we have talked about all episode, with the low battery warning in the app. There is a manual button on the unit for wet hands, and the brains talk to it by radio from indoors through the brick. One honest warning: it wants mains pressure at the tap. If your garden runs off a gravity butt with no pump, keep your money for now. No pilot valve timer will serve you well there. So what does that mean for your garden? It means the little box on your tap is cleverer than it looks, and you can trust it further than you probably do. 2 tricks: a magnet that remembers, so electricity is only spent at the moment of change, and a diaphragm that borrows the water's own pressure, so the batteries never lift anything heavier than a pinhole plug. 2 pulses a day and a bit of counting. That is the entire running cost of a watered garden. Next time, we ask this same valve one awkward question: what happens when the batteries die at the wrong moment? Because a latching valve holds whatever position it was left in. If it died shut, your plants go thirsty, which is bad. If it died open, the water keeps running until somebody notices, which is a lot worse. There are gardeners with eye-watering bills who learned that the hard way: fail open or fail closed. It is the one thing to know about any timer before you go on holiday, and almost nobody checks. That is next week's episode. If a bus driver taking a tap timer to bits on the kitchen table is your sort of thing, subscribe, and bring a friend who still thinks these boxes run on magic. Right, that is the route for today. See you on the next one.